Hello everyone, welcome to Knowledge Optimizer. I'm Rajat and today we are going to discuss about one more system design principle, that is reliability. So what actually is reliability? So suppose you are a user, okay? There is an e-commerce website. You are a user, you win. Now you added something to cart. Added something to cart. Okay. Uh, you added some item to the cart. After a while, after searching for all the product you want to, you added some of them to the cart. And when you went for checkout, basically check out all the items which are added to cart. Now you see your cart, whatever item you had added, some of the items were missing. Basically, they were not added in the cart. So we can see there is this inconsistency in the system. Now user trust would be lost. So there is this inconsistency, user trust will be lost. Basically he again has to add those, again has to do that process. So that will lead to many problems. You will lose user trust, then business and everything. User will check for some alternate solution for that. So that's the main idea behind reliability. So it is the, what is reliability? Ability of the system to perform correctly and consistently over time, also in case of high load. So yeah, how your system is showing the data, whether it is consistent or not over time, basically in case of high load, how it is performing. That's the main idea behind reliability. It should be reliable, then only you would be able to. So basically what are, why, first of now the second question is why reliability is that crucial, is crucial. I gave you an example, this e-commerce example. So here you can see, like, first of all, first, whenever your system is not reliable, then in that case you'll lose user trust. For basically gaining user trust, your system has to be reliable. Again, it just since user trust would be built, more and more users will, it will attract more and more user. Okay. Suppose, okay, there is an alternate website which is selling the same product as yours, but it is basically it crashes, or there is some inconsistent behavior, like in whenever user one is making R1 request with some parameter 123, and the response was R1, okay, RS1, but if it makes R2 request with the same input, then it is giving some res2 with which is not same as res1. So here the system is performing inconsistently. So then in that case, similarly this one also, then in that case users start looking for alternate solution. So if your system is running perfectly, so they will be attracted towards your website if you are providing alternate solution for that. So business, for business growth also, business continuity or growth you can say. Then compliance. What do I mean by compliance? Okay, actually, so suppose you are working with a healthcare. So if you have visited any a hospital, so you have seen there are some x-ray machines. Okay, now consider this x-ray machine is not performing consistently or correctly. Do you think, in case of healthcare, do you think you'll ever rely on this if it is not performing consistently and correctly? You never. So that's why it is must to perform those healthcare product, it is must for them to perform correctly and consistently. Basically they has to be reliable, else people will go for some manual option than these things, x-ray or any other things. So this is this basically in healthcare, the system has to be highly reliable. So compliance comes, it's the same. Okay, now cost of failure. If your system is not reliable, it basically crashes in case of certain high load. Then in that case, okay, if you want to again start the system, then in that case it requires some cost. So cost of failure is usually very high. So suppose Instagram is down, okay, all the server is crashing. Now to set up everything once again, to start up all the servers, it will require huge resources. So basically the cost is pretty high in those cases. That's why reliability is consistent. You have to build the system such a scenarios in such a way like it is consistent, it does not, it is fail, it should be fail proof, it should have some recover mechanism that we'll cover in fault tolerance, or in predictability we'll cover like how to design the system. All those things we'll cover in the later part of this video. Okay, so these are the few main part where it shows like where reliability is important. Okay, now moving on to what makes the system reliable actually. So we are talking about this here, reliability, but reliability this and that, but what makes a system reliable? How can you say your system is reliable? Okay, so first is predictability. What do I mean by that? If you can predict the behavior of the system before only, if you, what do I mean by that? Okay, suppose you are designing a system. Now okay, suppose there is user 1, user 2 are visiting this service, and there are multiple pods running. Then there is this load balancer. So just building a basic HLD diagram of a system. Then there is this database. Okay, DB layer. Now, if you have seen my scalability video, then you can see there are actually two single point of failure. One is load balancer. Okay, single point of failure. There are basically two single point of failure. We see like these arrow coming on this. Similarly, on load balancer also, there are two single point of failure. If we haven't detected it while designing your system, if you are not making these things in mind while designing a system, then that case your system definitely fail. It is going to be not reliable. Okay, at load balancer part only it can fail. Now no more request would be served by these users. Similarly, at database layer it can fail. So you have to keep these things in mind. So basically there is a concept designed to fail, design for failure. Actually we'll cover this also, design for failure. This is kind of some one key principle of reliability. So you have to design your system for failure also. You have to know, basically you should be able to predict the behavior of the system in case of, okay, this error came, now the system will behave in this way. So you should be able to predict it. So you have to be aware about all the scenario, all the fail cases and everything, and you have to handle them properly. Now availability. Your system should be available. Okay, what do I mean by that? Like your system should not crash. It should be available all the time to all the users. Now there's a thing like people get confused between reliability and availability. Okay, are they both same? No. Your system can be available, but it cannot be reliable. There are scenarios. But when your system is reliable, then it should always be available. Okay, what do I mean by that? So suppose you are running an e-commerce website and you take the stats of last 1 year, like how much time you saw basically system was down or not, and you saw like it was available 100% available. Okay, your system was 100% available for 1 year. We saw this data. Okay, but for 99.9% it was reliable. Now, what do I mean by that? For 0.1%, 365, 0.365 days, basically nearly for 8 hours, it was not reliable. Basically, it was available. It was showing stale data, some stale data you can say. Or if you have seen my scalability video, then you must know about the SCAP theorem. Basically, we are showing some stale data. System is available. This C stand for consistently available partition. Okay, now we are showing, we have introduced some circuit breaker. We'll cover this also. What is circuit breaker? Okay, we have implemented some circuit breaker and we are showing some data to the user. Though it is not consistent, it is not correct, then we can say it is reliable. We cannot say, but it was available. So it was available for 100%, basically for whole year, for 100% of the time, but it was not reliable for 8 hours. So that's the main difference between them. Okay, now moving to fault tolerance. What do I mean by that? Oh, actually failure are inevitable. Okay, you can build any system, but there will always be a possibility for that system to fail. There will always be that possibility. So fault tolerance basically determine like how, in case of failure, how your system is going to behave. What should be the restore mechanism, and all those things are done by this fault tolerance. Basically we'll read different strategies in the later part of this video for fault tolerance. So we'll cover that later also. So actually fault tolerance is nothing like how the system will behave in case of failure. Now consistency. This is actually from name only. You can, I think in the previous example also I just gave like, suppose you are user 1, you hit a request with some parameter p1. Okay, and you got a response re1. Okay, now this is user 1. Now user 2 hit the request r2. Okay, with same parameter p1, but it and it get the response re2. If re1 is not equals to re2, then it is not your system is not consistent. So to make it consistent, basically it will behave in the similar way. Or we can say like I give you an example of cart. So suppose an user has added 5 items in the cart. Now whenever he goes for checkout, basically 5 items should be available in the cart. There could be chances like earlier the system used to build like this only. So when in case of partition, people used to see this problem when they use the stateless system. Also stateless and stateful we described in the last video. So when they use the stateless system, and in case of these different partition, then in that case some of the items, since okay user 1 has added some item to this server card, and since it was not persisting in the database, since we haven't committed the transaction, so whenever user basically 1 hit this, now it is being served from here, then that case he saw like empty card, so it again add the item to the cart. So this is kind of some problem of consistency. So in your case it should be consistent. There are various mechanism to overcome this problem. Okay, we have discussed that too in last video. So your system has to be consistent. Now last is graceful degradation. What do I mean by that? Okay, suppose you are running a service. Okay, there are 5 servers running for that. Now your server 1 has the consider the case server 1 is serving 5 requests at this time. Now it saw some failure. Now it start basically in the termination state or invalid state. It saw it. Okay, but since those 5 requests are still on this server, so there should be some mechanism. Basically now there are different ways, like Kubernetes does it automatically. So there should be some mechanism for the server to at least serve whatever request it has got, though no new request will be redirected to this server, but whatever requests are in progress, that has to either to be reverted, like if there is some transaction going on, it has to be rolled back or it has to be committed. So that's the main idea of graceful degradation. Okay, so in case of Kubernetes, like you are if you have restarted your service, so you usually see like it take the buffer of 10 seconds to restart the service. So that's also graceful degradation, like whatever the requests are there on that server, that first of all those requests has to be kind of committed or rollbacked. Okay, it gives the time of 10 seconds before terminating the server. In these 10 seconds it will just process whatever request it already have, not the one, not the new one. Okay, now these are the few you can say things you have to keep in mind if you want to make your system reliable. You can, if you have covered all these, then you can say your system is somewhat reliable. Okay, now let's move to key principle of reliability. One is design for failure. So since failure is actually inevitable, So you have seen like WhatsApp goes down, Instagram goes down, and all those things. And you can see that traffic is usually unpredictable. Okay, at certain point you have defined your resources, you have limited your resources. So suppose I have enabled auto scaling, everything I have done, kind of 100 servers are running, but at a certain point, at a certain traffic, those 100 pods or 100 servers you are running, those will also be less for the such traffic. Then that case you kind of, there are multiple scenarios actually, there could be natural disaster also, there could be anything, power outage or anything could be there. Then also you have to basically consider all those scenarios whenever you are designing your system, and you have to design for failures, you have to design for all those scenarios. So like how your system is going to perform fault tolerance, basically we'll discuss now in this key principles only. Now there could be a way of redundancy, replicating everything, use it there instead of, in case of failure in the original one, you will use the backup one. That's called redundancy, we'll cover that too. So there are various mechanisms. Then circuit breaker, as told you earlier also. So they, like how you are going to design it, that you have to identify. And you have to keep this mind, like you, it shouldn't be like, okay, my system is going to perform like, or there won't be any failure, only these are the scenarios be hit. That can never be possible, you have to design your system for failures. Okay. So suppose, to give you an example, suppose you are building a weather service. Okay, yeah, there is a microservice m2, or this is user 1, and it is calling a third party. Okay, third party API for fetching the weather information. Now suppose this third party somehow at a certain time, this is taking, basically this is being timed out. Now since you are, and so what earlier, what you used to do, just user one request r1, then you get this information, you used to provide the response to the user. Okay, suppose res. Okay, r1 you are providing. Now it start taking some, it start giving timeout. Now in that case, the user one hit r1 request, you make the request to third party to fetch the weather data. Now it is being timed out. Since now this third party thing is not in your hand, so since you are not getting any response, so after a while even this request will be timed out. Okay, now you can see this is not a good, you can say, though it was not your fault, but it is not a kind of good experience for user. So what should you do? So people start building a system in which they introduce the database for this microservice. Now what they used to do, there are two ways now. Either a cron would be running after a particular interval, fetching the data from this weather service. Okay, and updating your data. Since let's not go there for now, consider this. Now what would be happening, so whenever user one is making the request, it will first of all fetch the data from this weather service, and update the data. First of all, it, at the same time, it will also make an update in this DB. Okay, r1 res1. Okay, now in case of timeout, now suppose there is this timeout, so we have introduced a circuit breaker kind of thing. What is circuit breaker is basically whatever system is filling, now it will pause. I'll just give you an overview. What does circuit breaker do? Basically, you introduce kind of breaker. So suppose this is a circuit going, this is M1 service, this is M2, or you can see current usually pass through this circuit. Okay. Now since this was not functional, so what you'll do? We'll just join it from here. So suppose you are building a circuit. Okay. If you have worked with, you have taken like science in your CBSE or ICSE board, like NCRT if you are it. So suppose this is a circuit. Okay, this is the whole circuit completed. Okay, M1, M2, M3. Now suppose M3 was not working properly. So what we'll do is, now these three were interacting. So we'll build a system in such a way, we'll introduce a circuit breaker for M3. Okay, Now no request would be passed. Basically this would be the circuit now. Okay. Now after a while it will check again. If now M3 is performing very well, then it will again create a circuit. Okay. Else it will going to survive this M2 only. So there would be the stale data it would be serving, or any other mechanism would be there, but it can serve stale data. M2 can serve stale data to M1. So in this case also, what we will be doing in case of if it is being timed out, now the circuit breaker we have introduced, now the things or API call would be served through this DB. Whatever the last updated weather report was there, it would be provided to that particular user on the basis of basically let long or region. We are going to store that weather information, and we are going to provide that response to the user. Though it is now, it is not consistent though, but at least we are able to serve the user. But at the same time, so this is okay, this works fine, this is strategy. But when you are dealing with the stock market, okay, you have a stock market website. Now here's this from this third party from where you are fetching this stock information. Now consider the case this is being timed out, or basically this is not provide, this is taking too much time. Then that case you cannot implement this strategy, basically showing the data which is there in the DB to the user. You cannot. It will lead to a huge loss of business for you. Okay, you are showing, there would be many legal cases on you, like you are showing some still stock price, so you can't do that. So does not work. So basically you have to identify for which system you have to implement what. So again you have to design for failures. In case of this we have designed for failure. There would be different strategy in case of stock market, definitely. So you have to build kind of so this is also, yeah. So whenever you are designing any system, and whenever you are giving the interview, you have to identify all the kind of bottlenecks, everything you have to identify how the flow will going to work. Okay, if this is a bottleneck, now since this is going to power everything, so if there is the chances of this failure, can I distribute it? First of all, there is a chance of failure, can I kind of, is there any backup for that? So you have to basically design these things. You have to design for failures. Okay. Now coming to the second principle, that is redundancy. So what is redundancy? Is there's nothing, just a backup component of the system, or backup component. Actually, not backup component. You can say backup of other system. Okay. System. Now it can be any system. It can be any component. It can be any microservice. So whenever there is a failure of system or any component or any microservice, basically the backup component, backup system or backup microservice will take over. So the main idea behind the redundancy is nothing, just it involves the backing up of all these component and bring them to use in case of failure. Okay, there would be a replicated or backup component would be running for the failure one. Okay, now that backup component will come to use whenever there is a failure in this failure on any component, or there could be microservices down. Then there is this how this different pod would be running for that. So that's the main idea behind strategy. So sorry, this redundancy. Now coming to what are the different types of redundancy. So redundancy can be of various types. One is hardware. In the hardware redundancy, okay. So we kind of like we are running some resource. So they are this hardware redundancy can be further divided into active. What do I mean by that? Is basically you are running the replication of all the components, okay, and those are running concurrently. If one fails, so you are running, suppose you are running a microservice m1, now you are running a backup of this microservice m1 also, okay, here. Now if there is any failure in this microservice, like this is similarly, it is all the traffic would be redirected here, so it is already running in progress, so this is called active active. Then there is this active passive strategy, sorry, active passive kind of a strategy for this hardware redundancy. Now what in this case, what would be happening, there would a microservice m1 running, there would be a microservice m1, but it is not in use right now, not in use until and unless this m1 fails. If it is fails, basically it will go up. Now there could be some latency here, okay, there could be some latency here, but again the resources, but resource utilization is high here. Since here resource utilization was not high, the here resource utilization is high. Now there's this hot spare also, you'll heard this from, it is similar to kind of this active active only, okay. So there is a spare component which is already installed, okay, and as soon as the kind of this already running component goes down, it will automatically replace that, auto replace that, okay. There is no manual intervention required in that, whereas this is cold spare. Here there is this manual intervention is required whenever the previous component goes down, then there would be, it will basically be not, it won't be auto replaced by this another backup component. Within someone has to manually kind of have to replace it. So this is kind of comes under hardware redundancy. Now there are actually, so software redundancy. So you have heard this term of replication, okay. So what we basically do, okay, so suppose you are running a database db1. Now since if it crashed, then in that case what we do, we basically create a replication. There could be ms strategy or if you have seen the security, master 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 slave replication can be there, okay. The we'll replicate all the data on the basis of different region also, we can replicate, okay. We can replicate in different region, and that will actually comes under this is hardware software that okay, basically you can do different, you can run in the same region. Suppose you are using a cloud service, you can store this replication in same region also, in different region also, or there are multiple ways also, okay. Same vpc or different vpc. Now db1 would be replicated. Now whenever there is this, suppose this is master right now and this is slave, okay. So whenever you see a failure, now this is start crashing, like this db is not functional anymore, then that case this will be serving as a master, replaced as a master, okay. Different strategy we can do that, like how to change the like what are the ways to basically leader election strategies, you can read about them. So I'll cover that too, not in this video but in different video, okay, like how zookeeper works, how this leader election strategy works. So now this would be served as master, since all the data is replicated here, now it will also, all the write would be call made to him. So this comes under software redundancy. Now you can even sorry, you can even replicate any software, kind of any microservice also if you are running, okay. Now it is actually also an example of data redundancy. So what people do is basically keep this data kind of this in this db1 in different region, okay. If you have heard this term disaster recovery, okay, dr environment, or region. So it is nothing, what it do is, you will running you would run your either microservice or database or some cache layer. Now suppose you are using elastic, then elasticsearch. So these since it is being served by this, suppose US East 1 region is serving all those. Okay, now there would be a disaster recovery region we have created, suppose East 2. Now all these microservices in your system, you can even consider some of the components also, like just replicating, just keeping the this backup of this database. But suppose we are keeping the backup of all this system. Now this microservice all be also be running in this region, this database, all the data would be replicated in this region also. Similarly for OS, though they would won't be serving anything as of now, but as soon as there is any failure in this region, in this US one, this region will going start serving all the requests. Okay, that is the responsibility, like how to distribute the load and where to hit what. That is the responsibility of load balancer. It can be done manually or it can be automated also. Okay, now actually, network redundancy. Now I have already discussed about load balancer in my last video, and I'll just give some more overview here. So suppose user 1, user 2, user 3, there is this load balancer running. So what does load balancer do is basically just distribute the traffic. Okay, whatever traffic you are running, suppose you are running 5 servers for the same e-commerce website, S1, S2, S3, S4. Now on the basis of what traffic it is serving and how much resources available on which servers and all those things, keeping them in mind, basically load balancer distribute the request and get the response for them. Now you can see the arrow comes in inverted arrow. You can see there are multiple inverted and this at this load balancer. So this is single point of failure. So then in that case we basically create different load balancer now, LB1, LB2. Now this LB2 will serve as kind of redundancy replication of this. Okay, now though request can be hit here, but in case of failure like LB is not working, then all the requests will be transferred here. Now and also with the help of some central tool, I will discuss about this. You will, this will go down, this load balancer will go down since it is not working, and new pod would be up for this. New load balancer will start in progress, it basically be started, this would be terminated, and some of the again the traffic will be distributed in this way only. Okay, you can read more about consistent hashing. It is being asked a lot and kind of system design interviews. Also how this thing is done, like suppose this is the leader, earlier this was the leader. So there's this strategy of leader election which is done by Zookeeper. Again, you can read more about it. I'll cover in different video of it, but you can also, if you want to look what does Zookeeper do. It is nothing. Zookeeper is just a managing tool for all these. In case of like if you have a partition system, then Zookeeper help in maintaining all those partition, all those things. Okay, like in case of load balancer, what Zookeeper does is basically it elects the leader, like which would be the leader election would be what the leader election strategy that would a part of Zookeeper. Okay, now the first, okay, leader election is done. Now second part of Zookeeper is and how you can say, like if the system basically starting, first of all spawning a new in this case they could be a failure of microservice, starting a new kind of server for that, and terminating the old one. And also there is this rule, like half of the server has to go down before you can call a system, like it is complete failure. Half of the system has to go down before that. Okay, now this is the main idea behind network redundancy. Now actually there are few more redundancy. One is geographical. Okay, So geographical redundancy, actually from the name only you suggest, even in the last example I gave, like suppose your system is running in US East 1. Now you have created different basic replication of this same system and US East 2, and you are serving things there, from this also. Suppose this the due to some outage, there's some natural disaster, this system goes down, like you have installed your server, okay, this location L1, L2, L3, okay. Now suppose uh, these servers which you have, or server house you can say, this is in New York, then this is in Delhi, and this is in Pakistan, okay. Now due to some disaster, this basically kind of this is completely destroyed, all this server house, okay. All the servers are completely like everything is destroyed here due to some natural disaster. But since you have already replicated your data in different other region, then in that case there won't be any loss of data, though there would be some time it would take to kind of replicate or set up all those things. But since there is no loss of data, kind of no loss of business would be there for you. So this geographical redundancy was also there. Then power redundancy, I won't cover this, from the name only you can suggest, like you keep the backup resources of this power, like even in your like home, you usually keep kind of generator if you have seen, okay. Those are also kind of power backup, also power redundancy also you are doing. These are all the types of redundancy. Now coming to strategies, okay, there's actually just three strategies: n plus 1. So suppose n nodes or servers are running, okay, or services are running, then you basically keep n plus 1 in kind of n plus 1, you uh, keep them in kind of ready state or active state, you can say. So whenever there is one server is terminated, the other extra one would be up, okay. Kind of you are just keeping a one replicated server here, okay, at a time. Now if one server is terminated, the other one will go up, okay. And there's this 2n strategy, okay. Now here you basically complete replication of system. You Here you do complete replication of system. All the kind of these other n will also be kind of in active state only. Whenever one all the n goes down, all the n goes up. Then there is n plus 1 m. Like m you have to decide on yourself, okay. And servers are running, now you are running 4 in backup, so suppose 10 are running, now you are running 4 in backup, okay. So these are kind of basic strategies. So main idea was to kind of understand like the type of redundancy. So these are kind of strategies of redundancy. So this is all from redundancy. Now coming to the second principle of reliability, that is fault tolerance. Actually third, first were designed for failure. Fault tolerance. What is fault tolerance? It is the ability of the system to perform in case of failure. Ability of system to perform properly in case of failure. Okay, this is basically fault tolerance. Now, what are the so from the name only you can guess, like tolerance against the fault. So there are different 8 strategies. Actually, why fault tolerance is important? First of all, for making the system highly available, then resilience to failure, then for business continue, for protection from business loss, user experience. So all those things, fault tolerance is required. So what are the different strategies? Like not strategy, actually how to achieve fault tolerance. So I think we have already covered redundancy. So like we discussed in the as the previous key principle only. So redundancy is again nothing, just a way of achieving fault tolerance. Is kind of a way to achieve a fault tolerance. So basically you are keeping a replication or redundant system, the critical, whatever the critical components are. First of all, you have to identify the critical components. So even when you are giving the design interview, so you kind of have to identify the critical components, and you have to create kind of replication. And in the last principle also we have read about active passive. Basically they are kind of multiple. In case of active, multiple, suppose this is S1 server 1, server 2, server 3 of e-commerce website are running. Now all the requests, since the requests are being distributed here, suppose this is not working fine, now these two requests will be now be processed by these two other, the one which is running. So this is active. Now in case of active, passive won't be serving any request. Okay, in the initial mode, whenever this went down, okay, this one S1 is going down, now it will come up this S2. Now all the requests would be served by this. So it's kind of active passive. So redundancy is kind of fun. Then there's this error detection correction. So actually you can so whenever there is an error, you have to kind of detect an error. Error detection and correction, what do I mean by that? So suppose if you have read about checksum. So okay, if not then also it's fine. Or hashes, considering the case you might have heard about hashes. So hashes is a way, kind of you'll just parse the data. Suppose you have encoded the data in some basic or some other format, and now you're passing the data and you are not able to pass it. Then there's a chances like the data is corrupted. So you again get the data, again fetch that data. So you have to detect the kind of error it could be lead to. Then in that case you have to invalidate this information. You have to again fetch the data. Suppose you have downloaded a file from somewhere. Now this is the corrupt file. You have to identify, okay, this is the corrupt file, there is a way to resolve it. Okay, no, then in that case you have to again download that. Similarly, checksum is also kind of works in the same fashion only from the name. Like for a large file, you just create some variable, assign some variable, create a sum of all those variables, identify if the data you get. Suppose again the example of you have downloaded some file. Now you'll see if the content of the file is corrupted or not. Hashes more works for security, whereas this more works for data consistency or data corruption, basically whether the data is corrupted or not. Okay, now you are going to identify whether the data is corrupted or not. And in case of, suppose you have downloaded a software, now you have seen like some of the libraries are missing whenever you are installing, so you again go and install that software. Since it is not unable to install the software, you will get sometimes this error. So this is due to this checksum validation only. You first of all identify whether you have to install that software, if there is some any issue with that software, whether it is able to process or not. So suppose you are installing a window installer and you see a corrupt message, you got it. That is also identified with various different strategies. So that basically detection of error and then correction of error that you have to do. Then there is this so you have seen like triggers monitoring or alert you have seen. So you basically trigger or create an alert in case of if you find any error, and also make the system in auto recovery. Okay, auto recovery mode. Basically if you see a pod is crashing again and again, like this pod is suppose you are running a pod and running a Golang service and it crashes due to some nil pointer dereference or exception. Okay, then that case this kind of there are different tools which keep in mind, okay, one pod is goes down, it will again auto start one more pod. Okay, auto start one more pod. And also it will here there would be a trigger mechanism, it will going to trigger or alert the different developer. Okay, so that you have to install for this. Okay, now replication again, data replication we have already covered. So what we do is So data replication or service replication. So suppose you have a database db1 in region 1. You now create a replication of this data. Okay, you create a db2 which is a replication of data 1 and in region 2. Now if this the db is not working in the same region, also you have created the replication. If it is not working, basically you start fetching the information from this database. Okay, so replication is also a way to kind of you can say a way to achieve fault tolerance. Okay, now graceful degradation we have already talked about. Self-healing system, again self-healing like I discussed here only. So they are self-healing system. Basically in case of failure, it will again, first of all, it can either restart another pod like we discussed about in the previous slide, or basically it will just cancel out that whole transaction, roll back to the initial stage, or it can auto scale in case of high load. In case of high load, we can keep them in auto scaling. Now it will auto scale, basically start adding more and more pod to serve the request. Automated recovery also it can do. Okay, so kind of these are uh, there are others also, like I gave the example of disaster recovery. Then there's a cloud based people start using stateless servers, the cloud services for this purpose only. So there's this disaster recovery region, you can create disaster recovery environment. Auto scaling you can achieve through those cloud services, they auto provide this that functionality. In the different region you can deploy your services to make it like more close to the users, to serve it, to decrease the latency, that we'll cover later. So these are kind of some ways to achieve the fault tolerance. Okay, now let's move to the kind of next key principle, that is graceful degradation. I think it would be just small in the starting of the video also we discussed about this graceful degradation, so I won't cover much about it. So it is again, so in case of failure, like your system degrade gracefully, failure or termination, like I give the example of nil pointer exception. Okay, you are running a Golang service and you got this nil pointer exception, nil pointer reference. Okay, now your pod just start crashing. Okay, now it won't be like it will just terminate this pod. Okay, there would be a, it will terminate it gracefully. There would be a timeout of 10 seconds usually it provide. Okay, in that 10 second, whatever the existing operation it is performing the server, okay, it can perform those operation and it would be terminated after 10 seconds. So this is the main idea behind this. Like in case of failure, the degradation should be gracefully. That case, like in case of failure due to one request, you don't want a other request which is serving by being served by this server to fail. Obviously you don't want that. And this, then again, consistency and synchronization. Okay, so I think we also have discussed about these two. Consistency is nothing whether your system is behaving consistently or not. And similarly synchronization, again to achieve the consistency, if you are if there is this, if you want to avoid the race condition, you want to make them synchronized, you want to put them in the synchronized block. If there is a resource which is being shared by different sites and you want to make it in the synchronized fashion, then and also avoid this race condition, you put them in the synchronized block. So that's the main idea behind it. So if you want to actually, yeah, that's all for the synchronization. So to make things actually thread safe, critical resources. Okay, now consistency and synchronization, again we have already talked about consistently, like how your system is performing. If your system is performing differently in case of at a different time, in case of same request being passed, like we have discussed, if r1 is passed, then res1, and if r2 with the same parameter path, then res2 should be equal. If it is not, then your system is inconsistent. Okay. If a transaction is committed, then it should be committed. If it is rollback, it should be rollback. Okay, in case of, if you want to understand, in case of database. Okay. So that's the main idea behind consistency. Basically, your system has to perform consistently over time. Then only you can say your system is reliable. Similarly, in case of synchronization, like if there is a shared block, then in that case, being used by different threads. If you want to prevent from this race condition, okay, what do, okay, if you don't know about race condition, so suppose there is a resource r1 being shared by different threads. So thread 1 just read the resource, read. Okay, now before he didn't even complete this write, basically thread 2 came, it also read this resource, thread 2. Okay, now it write the resource to r1, basically suppose r1 plus 1, all the threads are doing this. Now this is r1 plus 1. Now it was also this thread to also read this resource. Now it will also update it to r1 plus 1. Okay, but at the end, since both of these had used it, the final state should be r1 plus 2, but right now it's r1 plus 1 only. Okay, so this is kind of inconsistent. Okay, for the third thread, if it want to read. So to prevent such resources which are shared among different threads, so basically it is being suggested to use synchronized block. Okay, synchronized block or locking, different type of locking mechanism are there. Redis lock, we can cover in the red these locking mechanism, and what, why you use synchronization, where to use is async things in different videos. So these are kind of key principle. Now how you can basically test reliability. So there are different kind of tests, stress testing. In Netflix they basically do chaos testing actually. So you can read more about them. What is stress testing? Basically, from the name, we test the system till its point of failure. Similarly, chaos testing, basically we test the system with the high load. Then there are automated tests which are being written. Okay, so whenever you are deploying any service, automated testing pipeline would be triggered. See, in the basic kind of in the CI/CD pipeline, only we write those tests. Okay, testing pipeline will also be triggered whenever you are deploying anything to the prod. Similarly, we write unit test case to prevent from failures. Okay, whether how the system is going to perform in the certain sets of condition. Okay, so uh, so there are many organization again, like Amazon has geographical replication. Similarly, Google also maintains the reliability. In case of Gmail, it has to be highly reliable. I guess to give you an example, okay, we'll create from a very small this system. Okay, suppose you have built a system. Okay, now you have built a service s. Okay, there's user, there are different users. Okay, now you have built your system, ignore these users actually for now. Okay, so you have built a system, they are different lb1. Now they are different services as servers s1 s2. Okay, now they are different db1 and db2. Now you have, since you can see at this point they, these are single point of failure, so it could be n up to n also. Okay, so you'll start replicating them. Now there would be lb1, this is kind of currently consider the case it is running in active mode. Okay, similarly here also db1, this is also running in active mode, basically master slave kind of thing. Master will all the write would be taken place in master, all the read would be done from slaves. Okay, now this is basically at a one system you can do. Now consider the case. Now you are replicating it at two regions. Okay, this is region 1, this is region 2. So far it was just the data replication kind of. Okay, system replication or critical component replication we are doing. Now we are doing the geographical kind of replication we are doing for whole system. Now this is geographical replication. Now suppose here also if you are seeing, like, actually above it would be, okay, this is the whole system one now. Actually this is system 1, this is system 2. This is a system replication, not in actually in the same region. We are doing the whole system replication. My bad. You can consider this as disaster recovery. Okay, system. Okay, it is now currently in passive state. Whenever it goes down, it will be operating. Now we create basically region one. Now we will create different replication in the region. Now we are creating different replication in region two. If due to some natural disaster it is not working, then this region 2 will be operated. Now further there could be different other categories also. We can move it to a broader level also, starting from the components. Okay, load, we are just replicating load balancer. Now we have replicated whole system. Now whole system also we have replicated on different region. Now from the region, what I am doing, uh, basically they are this warehouse W1 in LA. So you have read about LA fires recently. Okay, they are this. Now they are this replication system LA2. Okay, warehouse. If all the servers due to some natural disaster are being compromised or are being non-functional, then in that case all the traffic would be served from here. So that's the main idea. You can keep them, replicate them on a broader level. Okay, and all the organization does that. Amazon have different servers in different region. Currently I guess it is running in the 11 region. The key warehouses they have the of different with the hundreds of servers they have. Okay, so similarly Google, and whenever you are making online payment where on the transaction, basically you are using kind of any payment method, then in that case payment gateway, basically your system has to be highly reliable. You don't want your transaction to be kind of cancelled, rollback, or in the intermediate, it being stuck in the intermediate. You don't want that. So that's all from this video. If you have any suggestion for the videos, or I'm missing any topic you want me to create any topic separately, you can just let me know. If you have any question in the comment section. Thank you all.